Hi students, today we'll be looking at Pop Quiz 2, Chapter 6, Chemical Bonding. So I'll be teaching you how to use the mind map on the right to apply to the questions. Because I believe some of you have some of these difficulties, so I'll be going through it step by step. So for question 1, they say element X forms the ion X3+. So now you zoom in at this one is a positive ions. So for positive ions, it means it must have lost electrons from metal. So it should be in metal initially. So in this case, since it has a charge of 3+, means it loses 3 electrons and it has 3 valence electrons. So my electronic configuration will be B2.3. So for question 2, an element Y reacts with chlorine to form an ionic compound with the formula YCl. And what is the electronic configuration of the particle Y in the compound YCl? So in this case, this one is an ionic compound, and Y, is already ions when they form this compound YCl. So we're looking at the ions. So in this case, the electronic configuration of particle Y in compound YCl, it will be a fully filled electronic configuration. So in this case, my answer will be D. So if they ask, what is the element Y, what's the electronic configuration of Y, then you need to give the electronic configuration of Y when it's an atom. But now it says particle Y in compound YCl, means you need to give the ions electronic configuration. So for question 3, first step, whenever you look at this type of questions, they give you the electronic configuration, or an diagram. The first step is to write down the electronic configuration. So it's 2.1 for X and 2.6 for element Y. So when these two elements combine together to form a compound, the chemical formula is, so in this case, first step is to identify whether they are metal or non-metal. So we know that when an element has a valence electrons of 1, 2, or 3, they belong to group 1, 2, or 3, and they are metal. So this is metal. So for metal, they tend to lose electrons. So in this case, they tend to lose 1 electrons. Lose 1 electrons. While for element Y, it's group 6 because it has 6 valence electrons, and it's a non-metal. So it tends to gain 2 more electrons. So now you see, one element X need to lose 1 electrons, but element Y need to gain 2 more electrons. So how do we balance the number of electrons to ensure that both the ones that we lose, the electrons that we lost, is the same as the electrons the other element gain? So in this case, we need to times 2 for element X times 2. So in this case, I'll need 2 of X and 1 of Y. That's why my answer will be option B. Moving on, question 4. Okay, so for question 4, the same things goes also. When you see electronic configuration, the first step is to determine whether is it non-metal or metal. In this case, 6 electrons, 6 valence electrons, and 7 valence electrons. So they are group 6 and 7, and they are non-metal. So when two non-metals involved in a chemical bonding, let's go back to the mind map. It will be a covalent bonding. Okay, so in this case, we have already determined that this one is a covalent bonding. That's why my answer will be C or D. So now, let's go through the procedure. Since element A, need 2 more electrons to share, so they need 2 more electrons, while element B, needs 1 more electrons for sharing. So how do we balance out the sharing? Since one need 2, the other one need 1, we need to balance in such a way that they have the same number of electrons for sharing. So this means that when one share 2 electrons, the other one must also share 2 electrons. If one of them share 1 electrons, the other one also must be 1 electrons. So we always take the smallest number and multiply in order to get the same lowest common multiple. Yes. So in this case, I just need to times 2. So this means that I need 1A and 2 atoms of B. So it will be AB2 will be option D. So 2 electrons, 2 electrons. So for question 5, right, which of the following best describe the bonding in ammonia NH3? So now we do some kind of a reverse mechanism. We know that N, right, is nitrogen, is under group 5. So it means that it has 5 valence electrons. 5 valence electrons. So now let me draw the N first. Just drawing the valence electrons. So yep. So now, right, I have 3 hydrogens that is sharing. So for these 3 hydrogens, right, it will be sharing 1 electron each. So this is a covalent diagram of ammonia. So in this case, let's check which statements will best fit this diagram over here. So nitrogen shares 3 electrons with each hydrogen atom. Is this true? No, because we notice that for each hydrogen, they only share 1 electrons. That's why my answer will be B. N form triple bond with hydrogen. This one is false. Because for one single bond, it means you share 1 electrons. So this so this one is one single bond. One single bond consists of 2 electrons. So 1, 2, one single bond, another single bond. Triple bond means, right, they must share 3 electrons each. Means, right, in the overlapping region, you should see 6 electrons. Okay, so some of you might ask, right, how do I know that hydrogen only share 1 electrons with nitrogen? Okay, so let me draw the diagram for hydrogen. It just only has like 1 electrons. So since it needs 1 electrons only, it will share 1 electrons with nitrogen. So there are 3 of them. That means each of them will share 1 electron each. So moving on to structure questions, true false statement. So let me bring you to the mind map. Okay, so which statements are true of ionic compound? Ionic compounds are solid. This one is true. Because ionic compound have high melting point and boiling point. So since it has high melting point, means you need high temperatures in order to melt it into liquid. So that's why at room temperatures, they will remain as solid. Ionic compound have low melting point. This is false. Ionic compound have high boiling point. This is true. So ionic compounds are soluble in alcohol. This is false. Ionic compound conduct electricity when solid and molten. This one is false. Because we know that ionic compound, they cannot conduct electricity in solid state. And the reason being, in solid state, all of them exist as, let me draw a quick one. All of them are held together by strong electrostatic force of attraction. So in this case, right, they can only vibrate at their fixed position. So in this case, they cannot like really move about. So that's why at solid state, they cannot conduct electricity, as there's no mobile ions which are free to move about. But for molten state, it's different. During molten state, right, it means that it must have overcome the strong electrostatic forces of attraction between positive ions and negative ions. So when that happens, all your ions will be like free to move about or slide about one another. So recall back to your kinetic particle theory. So that all of them are like in a disorderly manner or are able to like slide around one another. So that's why they can conduct electricity in molten state but not in solid state. So the last one is true. Ionic compounds conduct electricity when dissolved in water. So the water basically, right, break this lattice structure apart. That's why they are free to move about. Next one, covalent compound. Covalent compounds are solid. This one is false. Because covalent compound can also exist as liquid and gas. So you must consider liquid and gas too. So your gas will be a carbon dioxide and your liquid will be a water. So that is false. So covalent compounds have low melting point. This one is true. Covalent compounds have high boiling point. This one is false. Covalent compounds are soluble in alcohol. That is true because alcohol is a type of organic solvent. So you'll learn more about organic solvent in Sec 4 when we talk about alcohols and other organic compounds. So covalent compounds conduct electricity when solid and molten. This one is false. The reason being, right, even though it's like free to move about, but there's no like charged particles to carry the charged particles. That's why it cannot conduct electricity for either solid, molten, and water. Okay, so dissolve in water, it just means your aqueous state. So the word aqueous, it means water. So aqueous is what dissolved in water.